Um, so this first topic today is going to be topological coloring algorithms. And so topological coloring, if you've seen maps like this where we have a bunch of polygons and no two polygons share the same color. And so topological coloring basically computes a color index for each polygon that you can use to color polygons to create this kind of map where no two neighboring polygons have the same color, but at the same time using the smallest number of colors possible to achieve that. And yeah, so then I described that. So bring up my other PowerPoint. We're going to basically be trying to, in this exercise, kind of reproduce, especially the 1800s, and there are a lot of maps around the world produced with this kind of look. So we're going to try to do a quick reproduction of that kind of effect where you've got, a particular polygon might be green, but you see it's a little darker around the border of the polygon. It kind of fades into the center. So we're going to try to recreate this effect in QGIS, but we're also going to, there's kind of like a gray stippled line around the border of these polygons. And so we're going to use a data-defined override to create that effect. So I don't know, this may not be something in particular, and today in general, some of these things may not be something you are going to follow as recipes exactly for your work. But my hope is that as we get into these things, you start to see how symbology in QGIS works and how you can apply things like data-defined overrides to achieve different effects, and kind of find some inspiration and how to work with different things with symbols. So we're going to start out with topological coloring here. And so again, this is a way to color polygons in such a way that no adjacent polygons share the same color. And then we're going to look at this data-defined overrides. And in this GIF on the screen here, let me restart the slide. You have these little buttons next to a lot of inputs in the layer styling panel. And each one of these, if you click it, brings up this little menu, which lets you either choose a field to define that variable, or click on edit and open up the expression builder to write an expression to represent that. And it just allows you to do more and more with your symbology. So we're going to start in QGIS with, in the municipalities folder of our course data, there's a geo package and it has municipalities of Denmark. So I'm going to add this layer to my project. Maybe I'll zoom in a bit more. And so this technique would apply to really any country or any set of polygons. And so what we're going to do first is, if we look at the attributes for this layer, there are, let me dock this. So there's a lot of things like the type of feature, the region name, the name of the municipality, and things like that. But what we're going to do is run this tool on these that's going to allow us to create a symbol, a new attribute, a color index. Because right now, if I, for example, chose categorized and chose the municipality name field and click classify, I would get a map that shows a unique symbol for all the municipalities. But you can see that some of these have a very similar green next to each other, and there's more colors being used on this map than is really necessary. So it becomes quite loud. But if I go into the processing toolbox and search into, there's a cartography section in the toolbox. And in here, there's a number of features. Most of these have to do with the style manager, this thing we looked at last week that allows you to organize your styles in QGIS. And a lot of these have to do with exporting the styles from a QGIS project as styles into your style library and things like that. But what we're going to use is this topological coloring tool. So if I open this up, it's a fairly simple tool. It's going to take the municipalities layer, and I'm going to use the default settings, and I'm just going to save this out to my geo package. And let's see, let me put this. And I'm going to just call it colored. So I've saved it out to a geo package, and now I'm going to click run. So it tells me that 6 colors were required, and it adds this new layer, oops, to my layers panel called colored. And if I right click on this and open up the attribute table, we have all the same attributes that we had in the original, but off to the right hand side, there's this new column color ID that tool created. And so we can see that there are a range of 1 through 6 here. So I can use this with the categorized renderer to style these. So I can go back into here to categorized, choose that color ID column that it added, and click classify. And now I have a map that has just the minimum 6 colors, while no 2 polygons share the same color. Whenever you use this categorized renderer in QGIS, it's always going to add this basically a null values category. We don't have any null values in this data set, so I don't really need it. And you can always, just to show you that, if I right click on a layer in QGIS, there's this option to show feature count. So if you ever want to just quickly know how many features are in a layer, you can use this option, and it will put the number of features in brackets next to the layer name. So there's 99 municipalities here, and it'll show you how many are in each category. And you can see this one has 0. All the others have 16 or 17. So I can remove that just by selecting it and click the delete button because I don't need it. And then I can undo show feature count. So I've got my basic colors for my municipalities, and it's using the random colors color ramp, which is the default when you use categorized rendering. And if you don't like the set of colors it shows, you can of course go in and change them individually. But you can also click the little drop down next to the color ramp and choose shuffle random colors. So you can shuffle this until you get a set of colors that appeals to you. So with that, we have our basic map created, and now we can have a little more fun with it. So I'm going to duplicate this layer. So I'm going to right click on this layer and choose duplicate to create a copy of it. And I'm going to turn off this original one and just work with the copy here. Look at my notes. So whenever we have a layer that's categorized like this, we can go in and change parameters of each individual symbol individually. But this button here becomes like a master symbol button that I can use to change parameters of all these 6 classes simultaneously. So I'm going to click this master symbol button and select the simple fill component. And now I can change this to a different symbol layer type. So we looked at shape burst fills last week. So I can choose that shape burst fill symbol layer type here. It keeps all the colors, but it's turned the symbol layer type to shape burst fill. So it's now using that to render all these polygons, but keeping all the colors that were in those classes. And I can then just go down here and change some of the parameters of this shape burst fill. So the distance here is a little large for what I need. I'm going to reduce the set distance here. And then I'm going to just play with the blur strength a little bit, increase it. Again, this blur strength is going to control how smoothly those colors fade from, in this case, the color of the feature to white. And I'm going to put this up to maybe 5 or 6 to create a smoother effect for each one of those polygons. And then I can click this go back button to return to the master symbol. And I now have shape burst fills for all these. So the next part of this is going to be creating a random dot boundary. So I'm going to duplicate this layer again, the one that I just was working with. Choose duplicate. So now I have colored copy. And I'm going to move this so it's the topmost layer. And it has the exact same symbology because it's just been copied. Make sure I didn't miss something. So here I can, I don't need this one to be categorized. I'm going to use this marker line to create that kind of stippled, kind of pencil-like outline around each polygon. So each polygon is going to have the same symbol for this layer. So I'm going to change this from categorized back to single symbol. And so it's going to turn them all to a single color. And what I'm going to do is select this shape burst fill, and I'm going to change the symbol layer type for this to outline marker line. So you can see there's a whole variety of outline for when you have polygon data. You can, if I wanted, for example, just the outlines, I could change it to outline simple line, and it would just wouldn't have a fill. It would just be the line border of each polygon. There's raster line, which allows you to put a raster image along the border. But we're going to use marker line, which lets you use individual markers, which are basically point symbols. So it allows me to put a point symbol along the border of my polygons. And the default is a big red dot. So we get this big red dot boundary around all of our polygons initially. But we're going to change that. We're going to refine the marker line symbol. So this marker line, just like any other symbol layer type, has specific settings that you can change for it. So first of all, we have this width interval. So this is one way of placing markers along the line. If I increase this, it's going to spread those points out and make them, 5 millimeters apart on the screen instead of 3. There's other options for placing this on different components of different vertices here. So you have probably every option you could ever want to place those along polygon edges. We're going to reduce this all the way down to 0.1, make it quite small. And so because we have big dots right now, it almost becomes a solid outline because there's now so tightly fitted around the boundary. So now we're going to choose this simple marker component, and I'm going to, I can start by just reducing the size of the simple marker to like 0.15, just make them very, very tiny. And at this point, maybe I can zoom in and, we barely even see them because they're just these small points. So we almost create like a solid polygon boundary because of our settings at this point. I'm also going to change the color of these to gray. So I'm going to make them 90, 90, 90. And so just a little color theory here. So with RGB values, again, if you choose 0, 0, 0, that would be black. If you choose 255, 255, 255, that would be white. And if you have all these three values, so basically if they all have the same value, RGB, it's going to be somewhere in the black to white continuum. So if I use this value slider here, you can see it's going to keep those RGB values all the same number. And so if we put them at, I was going to put them all at 90, that creates kind of like a dark gray color. And I'm going to make the fill the exact same. Here I can just choose pick color, click on that to make them the same. And next, this is where the magic is going to happen. Let me copy this expression. So for this simple marker, there is this section down here, which is an offset. And this allows you to offset the marker from the polygon edge by in either the X or the Y direction. You can see there's some other things here. There's rotation. So since we have just a circle, rotation wouldn't change anything. But if you have a triangle, for example, you could rotate that in different directions. And as I was mentioning, with each of these, you can see that there is this little data-defined override next to them. So for rotation, for example, if I had an attribute field in here that had a rotation value, I could point the rotation parameter of this symbol to a field that contained the value that I wanted to use, and maybe that was going to be different for different features. And the same is here for offset. So for offset, I'm going to use an expression to create a random offset from the polygon edge. So I'm going to use an expression to define the offset. And I'm going to explain what this expression does, but it's using a couple of functions in QGIS. It's using randf creates a random floating point number. So it's going to create a random floating point number between 0 and 1. And then it's going to, here we need an X and a Y value. So the first one for X is going to be a 0. And then for the Y, it's going to be this random floating point number, 3 to the third power. So this took a while to figure out, but you can see down here in the output preview, it's giving me these two numbers, one for the X and one for the Y. So if I click OK, it's now moving these tiny little marker lines off the polygon edge randomly within a certain tolerance. And it creates this kind of cool effect, and it matches the width of the shape burst fill. So the shape burst fill, to review that, had a set distance of 3 millimeters. And here in this expression, I think I have it in a slide actually. So this expression is basically taking the Y value and giving a random offset value to it. And it's the fact that it's being multiplied times 3 corresponds with the 3 millimeters of the shape burst fill. So we get the same dispersal of those random points within that same tolerance. for the polygon edge. And so again, we're using a couple functions. We're using concatenation here. So concatenation is just a function that glues different pieces of text together. So anytime you want to have a series of text elements in an expression combined, you can use concatenation. Text in QGIS always gets surrounded by single ticks. So we're basically having a 0, comma space here concatenated with what this expression generates, which is 3 times a random floating point value between 0 and 1 to the 3rd power, and it creates this small decimal number, between 0 and 3. And so it's going to effectively create this random floating point dot boundary. So this is one example of using an expression to define symbology. And I should also point out that there are other interesting expressions in here. So you can see if I go to the simple marker, there's data defined overrides for every one of these. And now that I've created this and used an expression, it turns yellow, and I have a little expression symbol in the middle of it indicating that there's an expression that drives this. And you can always go in here and either deactivate it or edit it and open up the expression engine again and change the values. So you could experiment with changing some of the numbers in here and seeing what happens. Anything like this usually takes time. It took much more time to develop this than it takes to show you how to do it. It's all, becomes kind of experimental at a certain point. But I want to point out that there's a color section in the expression engine. So two that people use quite a bit are darker and lighter. So these are 2 functions that will make a color darker or lighter by a certain factor. So sometimes you may have the same color for an outline of a polygon and the fill of a polygon, and you can use let's say the darker function for the outline to take the same input color as the fill, but make it darker by a certain percentage. And if you have a series of polygons with different colors like we have here, you could give each of them a darker outline than the actual fill color, all with the same parameters by using a darker function to define the stroke color in this case. So there's a lot of ways that you can use these different functions for symbology.
Can I just ask why your expression is to the power 3?
You can, and I'm not sure I can even remember why, to be honest with you. That's something I should be more prepared to answer if I'm but it's
so that I was going to say, is it just so that you get more dense points nearer the line?
Yeah, exactly. So it does then. That's exactly right. Yeah, so it creates the densest array of points along the edge, and then they're random but thinning as they approach the interior of the polygon.
Yeah, because if you've got like 0.5 to the power 3, it goes towards 0. Basically, everything goes towards 0 unless it's like over 0.9, I suppose.
Yeah.
So it's, okay, right. That's a nice little expression.
And I honestly didn't even come up with this myself. There's a QGIS developer who does a lot of symbology, and he tweeted this out a number of years ago on Twitter. And so his expression was using some different variables, but yeah. So sometimes I get things like this just off of Twitter when one of the developers posts something that is interesting.
Yeah. Yeah, well, I seem to have just noticed most cool things now from people posting stuff on LinkedIn. So yeah, that's where it all happens.
It is. Okay, so we pretty much have the final effect here. We just need to control some of the things like blending modes and opacity with these different layers. So for this colored layer, which is solid, it's the original one from the topological coloring tool. I can go into the layer rendering for this layer and make it semi-transparent, knock it all the way down to like 25% or so, and give it a blending mode of multiply. I'm going to add a base map to this later. So when I do that, you'll be able to see the base map through this because it's using both opacity and blending. If I choose the colored copy below that, I'm also going to give this a multiply blending mode. So they'll both be multiplied and you'll be able to see what's underneath them. And I'm going to give this some opacity. Turn that, yeah, turn that off. So we have largely created the effect, and now there's a plugin called Quick Map Services. I don't know if I mentioned this last time, but if you want quick base maps, this is a good one to use. So I'm going to use on the OpenStreetMap standard base map here. It ends up at the bottom, and so because I've used the multiply blending modes, I'm able to see the base map through all of these layers. And you can even tweak the stippled outline a little bit by experimenting with blending modes for that. So I could try like a blending mode of hard light to just soften the boundary a little bit. So it's always worth experimenting with those sorts of things. But within a few minutes, we've created an interesting little cartographic effect. And of course, once you've created something like this, you can save it as a style. So again, I could go in here and for this kind of complicated symbol, I can choose save symbol and save it into my when you say this is if you're using a QGIS 322, you won't see this. I'm in 328 right now, and there was a recent thing where you can have project styles or just default styles for your profile. So I'm just going to choose the whole profile, and I can call this random marker outline and save it maybe as cartography, give it a tag, add it to favorites and save it. And now I should see this as an option down here that I could apply to another layer. So I don't have to go through all the work every time. So that is a little bit of expression. And next we're going to switch gears into geometry generators, which are really one of the more exciting ways of symbolizing data in QGIS. Let me find the start of this section. So geometry generators allow you to do almost anything with symbology, including things like these Tanaka contours, which is a way to symbolize elevation data using this technique an old Japanese cartographer Tanaka developed in the 1950s, and they're called illuminated contours, and it kind of creates this terracing effect with elevation data, which is pretty cool. So you can use geometry generators to replicate this in QGIS. It's quite complex, but it can be done. I showed you the exponential coastline buffers at the end of last week's session, and this is also achieved by geometry generators. And there's actually, if you open up the style manager in QGIS and browse online styles from there, you'll end up at this website. There is a style for these exponential coastline buffers that you can download, and you have to tweak some of the numbers in the geometry generator depending on what coordinate system your data is in. But you can get a lot of the logic immediately from that. This is the expression that's used here. So you can use this one is quite complex, but we're going to start with some basic ones so you kind of get a feel for how it works. But just to give you some examples, well, maybe let's start with some of the simple examples in QGIS Live, and then I'll show you some more food for thought. Well, I didn't mean to do that. Okay, so I'm going to start a new project. And yeah, we're just going to be using this same municipalities layer that we just used in the previous exercise. So we've got polygons here, and let me make this black with a white outline for now. And I'm going to duplicate this layer and make the copy the uppermost. I'm going to rename this centroids. And I'll turn it on. And so for this duplicated municipalities layer, I'm going to choose the simple fill component and change the symbol layer type. So we've looked at marker line, we've looked at shape burst fill, and now we're going to look at this one at the top called geometry generator. And when we choose geometry generator, we get some interesting choices. We can choose the geometry type. So this is a polygon data set, but I could choose line or point. So if I choose point, it's going to give just a basic marker. And initially it puts markers, it's kind of like choosing the outline marker line. It just puts markers around the border of each polygon. And we have this expression box down here. And so this is dollar geometry is the geometry of each feature in the data set. And we can use this expression engine button over here to open up that expression window and start building an expression to change how this layer is symbolized. And if I go into the geometry section of the expression engine, so we just looked at color a little bit, and now we're in geometry. There are a ton of geometric expressions in here. This grows every release of QGIS. But there's one for centroid. So I can put my cursor at the beginning here and double click centroid to feed the centroid function into QGIS. And the help is quite good here for figuring out how to use each of these. So the centroid function just needs the geometry. And I already have that. So I can just close the parenthesis. And now my output preview just says geometry point. So I can click OK. And it's now rendering my polygons as centroid points. And this can be very handy because you don't necessarily have to create a new copy of the layer. You can actually compute centroids in QGIS as a new point layer. But here, if we just need it for cartographic purposes, we can just symbolize the centroids. And you'll notice with, where is an interesting polygon? So it's like down here, sometimes there's an odd shaped polygon and the centroid can actually fall outside the polygon in some cases. If you have like, especially like a U-shaped feature that can happen. I don't see that exact case here. It's almost happening up here where the centroid is about almost to fall outside the polygon. And there are definitely weird shaped polygons where the centroid is actually going to be outside the polygon. So here, what I can do is use a different renderer. I'm going to rename this layer whole of accessibility. And I'm going to select the geometry generator, and I'm going to open up the expression engine again. And there is a related function to Centroid called pole of inaccessibility. And if I read the help, it calculates the approximate pole of inaccessibility for a surface, which is the most distant internal point from the boundary of the surface. So this may be more what I'm looking for, so I can try this function. So I'm going to replace Centroid with pole of inaccessibility. Again, feed the geometry into it. This function needs a second argument. It needs the geometry and some kind of tolerance. So I can just put a comma after geometry and just put a tolerance of 1 and click OK. And I'm going to make these yellow so we can see the difference. So now you can see for this polygon, yellow is the pole of inaccessibility. It's a little more where we'd expect the center of the municipality polygon to be versus the centroid. And so, QGIS will just calculate these on the fly for each feature.
Why is the yellow dot the more expected?
Well, I mean, I guess maybe that's the wrong term, but if I'm looking for something that really falls in the middle of a polygon, that pole of inaccessibility function is going to do that for me, whereas centroid can be a little confusing sometimes if that's what you're trying to achieve. Not exactly correctly stated by me there. So another thing we can do here is we could, instead of choosing a point geometry, we can change the geometry of these features, but create like a buffer instead. So I'm going to rename this buffer. And for this copied version of municipalities called buffer, here I'm going to, instead of choosing point for the geometry type, I'm going to stick to polygon. And there's a buffer function in QGIS that lets me buffer features. And oops, lost my dollar symbol there. And buffer just requires 2 arguments as well, the geometry and then the buffer distance. So if I use a negative buffer distance, it would create internal buffers. If I use a positive buffer distance, it would be the standard external buffer. So let me see, what's a good, let me try like -1000. And give this a lighter color. This one takes a little longer to compute, but now we're getting an internal buffer of 1000 meters for these municipalities. So you can, come up with a lot of different effects using these. And so I want to give you just some food for thought on some more, certainly more complicated, but more interesting and practical use cases as well. So this is an example from a cartographer who worked for the New York Times. And at the beginning of the pandemic, he was interested in how people were moving from New York City out to the suburbs to work from home. And so he had their home address and their work address and home address, and basically used a function in QGIS create line. You can create lines from points, and then he symbolized them as arrows and kind of came out with this visualization of where people had moved out of the city at the beginning of the pandemic using a geometry generator. So the arrows are being generated on the fly without having to actually create a line data set for that. This gentleman, Michael Stutz, has a GitLab repository, and let me open this up because this is really handy. This is I'm going to paste this link into the chat. He has a lot of geometry generator examples, and some of these are pretty amazing and very useful. And for each one of these, you can just download the style, import it into QGIS, and apply it to your data, and then look at the expression to see how he created it. So for example, polygons, the green polygon is the basic symbology, but the geometry generator allows all this around the perimeter, the dimensions of the polygon in meters, including the label and the arrows and the edge lines, to be put on to the polygon onto the map. So that's pretty cool if you're doing kind of municipal planning or something like that. The same thing for lines, just displaying the length of different line segments on the map. One arrow per line of a polygon. There's other ways to do that now, actually. Labels with a leader line. There's actually, call out lines are available in QGIS, but he's able to do it with a little more control this way. Kind of an effect very similar to what I just showed you, created with a geometry generator instead of a data-defined override. These are points being styled as actual buildings. Moving things. So this is another almost effect similar to the point displacement renderer. So he has a whole series of these that you can use for inspiration. And if you want to work with any one of these, you can, these lines in this case are being created. So it's a line connecting to the nearest neighbors of each point. So it's a fantastic gallery, and you can, like I said, download any of those and use them. So that's a really good resource. I have a couple more examples. This man, Johann Kroger, also plays around with kind of more creative, abstract geometry generator examples. One of the things a lot of people are into is creating these Joy Division plots of elevation. There was a punk band called Joy Division in the early 90s, and they had this classic album cover like this, and now people are recreating that with real GIS data. Creating Lego maps of areas, you can do that with geometry generators. Whoops. And
that's a very Danish thing to do.
Of course. Yeah. And digital rain. Yeah, I've created a map of Denmark in a Lego style before because I had to. So there's a lot of interesting use cases for these. This gentleman, Topi Chukhanov, who he's Finnish, and he created the November Map Challenge, and he has a lot of creative, useful ones as well. So you can browse those. Have you guys heard of cartograms? So a cartogram is where you change the size of a polygon feature based on a data value. It's used a lot for election data, for example. Here, there's a new function in QGIS at 324, scale. And so here I'm using a geometry generator to scale the municipalities by the population density. So as the more rural municipalities, it shrinks the red boundary to be smaller, but it's still the same geometry, just shrunken. And that's again done with a geometry generator expression. And in the Q&A, I showed Blanca this 2 days ago, but there are these new wave functions in QGIS. So you can use these with the geometry generator to enter the function wave against the geometry and then put in values for the amplitude and frequency of the wave and change the way the waviness of a line will look. So you can do a lot of effects with this now. And so certainly for coastal cartography. There's probably a lot of interesting use cases for this. And there's a whole series of these related functions. There's wave randomized, square wave randomized, triangular wave. Yeah, so a lot. Another really useful one that I have an example of it somewhere I could bring up, but there is in the geometry section in here, if I open up the expression engine, and go to geometry, there is this function called wedge buffer. So if you have photo points that you want to visualize on a map, and if you have as an attribute the azimuth that the photo was taken in, the direction the photo was taken in, you can use this wedge buffer function in a geometry generator against those photo points to create a cone that, so a wedge buffer is basically a cone, and you can orient it in the direction the photo was taken so that you're showing the field of view of the photograph on the map. So that's a really practical one as well. But there's endless use cases for these, especially when you see all of the different functions there are in here for manipulating geometry. Let's see. We're kind of near the top of the hour. Why don't we take a 10-minute break, and when we come back, I'll show you how to work with the temporal controller and animate time-based data.
Yep, sounds good.
Yep, all right for me as well.
Thank you.
So did you say how many minutes? 10 minutes? 10, okay. All right. See you in a bit.
Yes.
Good. Could you show I imagine this is the wedge buffer that you've just done.
Mm-hmm.
So is it like the angle that you tell the map to, like how to rotate that? But I wanted to ask about it, but then I'm gonna have a coffee first. So this is, did you put the angle or like a rotation something, or?
Yeah, so this data set is photo points, and the red dot is the actual just point. And if I open up the attributes, this data set has an altitude, direction, rotation.
Altitude, how is that relevant?
Well, it's not here.
Okay.
But this was all data, if photos that are geotagged, all that data is in the EXIF format in the file. And so there's a processing algorithm in QGIS called geotagged photos. And so you can just point it to a series of photograph files, and it will create a point data set and extract altitude, direction, rotation, lat long. So that's where that came from. But I'm just using the direction.
Oh, the direction, yeah.
So if we look at the geometry generator.
Sorry, but so you have to have it in the data set prior. You cannot decide kind of like afterwards, looking like you would want to skew it slightly or something.
Oh, of course, yeah, you could go in and just add a new column and for your photo points,
change the value.
Yeah, of course, yeah, that's certainly doable. So this wedge buffer function that I'm using in the geometry generator, so I have a point data set, but I've chosen the geometry type as polygon, feeding it the geometry, and then the wedge buffer takes a couple different arguments. One is the direction of the wedge buffer, and so I'm using that direction field here. So again, in QGIS, fields are in double quotes, so that's that direction field. This is the angle of the wedge, 45 degrees, and then 400 is number of meters out from the point. So there's actually a wedge buffer processing tool in QGIS. Create wedge buffers, and I could just create a static wedge buffer file. But here I can experiment. I can say, well, 400 meters is a little too far. Maybe I should just have that be 300. And maybe I'd rather have the wedge be 60 degrees wide instead of 45, and or whatever. And I can just change all of these parameters, boom, on the fly until I have it looking the way I want. And then the shape burst fill creates a nice effect with how that polygon gets rendered. And I actually had taken this one a step further at one point. There's a raster image marker component here too, where I actually display the photograph on the map instead of the point. But the path is wrong right now, so it's not finding it. But I've got data defined overrides for the size of the photo image and the rotation of it in the same direction as the wedge buffer. So that's about as far as you can take this, but it can be a really nice way to show photo points on a map, and so people can see which way the photos are taken. And just another, this is kind of a silly one, but it's still kind of amazing to me. This is just a map using raster image markers for a point grid over Denmark, and using the QGIS logo as the raster image marker. And then for the rotation, I'm using a data defined expression here. So there is actually a canvas cursor point variable in QGIS, which is wherever your cursor is. And then I'm using this azimuth function. And I think the 57 degrees is the angle of the Q coming off the line of the Q coming down. And so it follows your QGIS cursor. So again, this is not something you'd ever use for work, but to me, it's kind of cool because it's kind of fun, and you can see how far you can take these kind of symbols, and even with a fairly simple expression, create something that a lot of people wouldn't even think was possible. So that's kind of a short summary of data defined and geometry generators. So we're now going to shift into using the temporal controller, and you will probably see this little clock up here that will open up the temporal controller panel. But just to orient you, this is a buildings data set. So it's just a series of points, and they're styled by the year of construction. So they range anywhere from 1001 to 2020. And most of these start around 1850. There's not a lot of those old buildings here, one or two churches. There's also this little filter icon here. So in this data set, the value 1000 was chosen as a no data value. So I'm filtering out, even though that could be a valid construction date in this part of the world, filtering out that value because it's just no data. And then one other point on the symbology before we get into the temporal controller is we're using a graduated renderer with the building points from red to green. And down here, when you're using a graduated renderer, there's this advanced section, and there's something down here called symbol levels. And if you open up symbol levels, this allows me to tell QGIS what order these points should be drawn in. So here I want the most recent points, the green ones, to be on top of the red ones. So when you open up symbol levels and enable it, I can say the first thing to be drawn is 0, the last is number 8. So the red symbols get drawn first and the green symbols get drawn last. So you can go in and just define what order these things get rendered in, so that a certain kind of feature is drawn on top of another in this case. So that's another little trick. It's
interesting because my mind had exactly the first question when I looked at it, because I would do it exactly the opposite. I would I would always put the oldest one on top of each other, as they are more historical and more valued than the newer ones. So I was like, it was the first thing, and I was like, why do you have the old ones, like the new ones covering the old ones? But I guess it's just you can change it easily. And I was just like, it was my first thought. I was like, why is it this way? I would do it completely the opposite.
Yeah. Well, let's just change it for just to show. There you go.
Yeah.
So then I have a base map, OpenStreetMap. So first I'm going to open up the layer properties for this buildings layer. And there is a temporal tab. So this is where you can enable time for this layer. So I can check dynamic temporal control. And let's say you had like a series of historic era photos, like you have one from 1930 and one from 1950. If you didn't have any time associated with that raster, you could still enable it. You could just tell it's a fixed time range and tell QGIS what the date of that particular feature is. So even if you have a data set with no time associated with it, you can choose just the fixed time range option and tell QGIS what time that feature should be active during. Here, there's another option, single field with date. There's also separate fields. If you have a separate field for the start and end time of some phenomenon, or sometimes people have data that has a duration, how long something lasted. So there's a lot of different options in here. Probably the most common is either fixed time range or single field with date. And so here I have a date column in the data set. And importantly, the temporal controller only recognizes fields that are of the date time format. Sometimes you might have a field where the date is just expressed as a string, some text. And if that's your situation, you have to create a new column and calculate that as that string value, convert it from string to an actual date format. So in the expression engine, there's a format date function that you can use to do that. Here we have an actual date function, so we're fine. There's also an option here to accumulate features over time. So if I uncheck this, as I animate things through time, it would just show the features that are active. Let's see, if the map is currently showing the year 1900, it would only show the buildings that have that date represented in them. If I choose accumulate features over time, it will just start adding features to the map. So you can choose to do that any way you'd like, and then click OK, and we're gonna see a little clock icon now in the layers panel that indicates this is a temporal layer, and QGIS knows what time it is. So now I can open up the temporal controller panel. Time is deactivated in the panel by default, but I can turn it on. And this first position basically lets me just set the time. Here it should automatically use the settings I've already created. So you can see that it goes from 1150 to 2020. The feature you're using in the temporal controller most often is this third option here, where you get the animated temporal navigation, and you have a time slider, you have play buttons, and you can set the range in here. So in this one here, where you can see the current time frame is 1150, the beginning of time for this map. This is the old church in the center of town, but there's not much else that's that old. So I could choose to put a custom animation range in here and put 1850 instead of 1150, and I start the map with a lot more points. I also have control over how big the step is from frame to frame to frame. Here it's set to 1 year by default, which works good for this case, but I can also choose decades, centuries, all the way down to milliseconds. And then you can increase or decrease the step from there. And then I can just start pushing play to have time start playing, and you can see it's 1854, 1855, 1856, and points start getting added to the map. I can also pause, and I can just kind of scrub through time to start seeing different buildings added. And this will just, go 1 year at a time, doing it this way. And then, let's see. Another thing that's really useful though, if we're going to create an animation, we're doing all this in the map canvas. So we don't have all the tools that we might have in a print layout. But there are ways to do things to the map canvas in QGIS. So if you go to the view menu, you can go to decorations, and I could add a title label. You can add the name of the town and choose the font that I want to use. Click apply, and it will add the font to the top of the map. I can change the color to white and make it bold. So now I have a title on the top of my map canvas, and you can do similar things. If we go to the view menu again, under decorations, you can add the scale bar, you can add an image, a north arrow, all sorts of things. So for example, here, I already have a legend image in the course data. So if I go to courses, data visualization, data, I have a legend JPEG that I just created from a print composition that I can add to this. And then I can hit apply and see where this ends up. It's pretty small, so let me increase the size. Here it is in the lower left. And I can use these horizontal and vertical positions to shift this around on the map, and maybe I can put it into an empty space or something like that. So you can position these kind of why isn't that not taking that? You can also choose which part of the map it gets, these little features get placed on. Horizontal only lets me go. Oh, interesting. I'll just keep it at 0 for this demo. Put it in the corner. And then if you want to create an animation, the way this works is you click this little diskette button, and it will bring up a dialog to export a series of still images per one for each year from 1850 to 2020. So it would create those series of a few, 150 or so images, and you just choose the folder. Should be an empty folder that you create for this, and it'll just dump all of those PNGs into that folder. And then there's a couple ways you can create an animation from a series of still images. You can use Adobe Photoshop or the open source GIMP, which I have directions for in the materials. There's also a command line software called FFmpeg that you can use to create like an MP4 instead of a GIF. So there's a number of ways to do that you'll see. And you can also specify the extent. So maybe the current map canvas extent, or you can change those values. You can control the dimensions in pixels of the output image, and even the time range down here. So all those options you have, and then it would just export all the images.
Can I ask again that you said that how to create then from the images to more of an animation? You mentioned a couple that are open sourced. What are the options for cases? Because I cannot use anything that is open source because of the confidentiality of some of the information. I cannot upload anything online, and I cannot.
But well, you could use GIMP.
So
because GIMP gives it like an open source version of Photoshop. So it's open source like QGIS, but it's just a desktop piece of software.
Okay, but it's a desktop, but it doesn't like kind of, I don't have to, but see some of these softwares are in a way that you're kind of like uploading the information online, and then.
No, everything that that I have in the materials will be just local on your machine. There's nothing being uploaded anywhere.
Awesome. Okay. Yeah, that's
so
what I meant. I never worked with this one, so I have no idea. Okay, well, I'll check it out.
There's a really, I can't remember if this is in the instructions. Let me see. I'm going to enter this link. There we go. Kane, this is one of your fellow countrymen here. This gentleman, Alistair Ray. He has a great little blog, stapsmapsandpics.com, and he has a really nice little article here on downloading and configuring FFmpeg. It's pretty straightforward. So this ends up being just a command line software, Blanca. So you don't have to, again, you're not uploading anything. You just install this command line software on your computer and then run it. And he has suggestions for how to format your commands to generate like an MP4 from a series of images. So that's another way of generating it. But the instructions I'm going to give you are for the software GIMP, and it's very straightforward. There's only a few steps that you have to take, so you shouldn't have any problems with that. And so there's a lot of different ways you can use temporal data. This is just one, this building footprint example. Oh, actually, there's one more thing I want to show you that's quite important. Is we don't have a label here on the map for time. And so we'd really like to know what the time frame is. That's kind of important when you're doing a temporal animation. So I can just create a new layer for time. And so for this demo, I'm just going to create a temporary scratch layer, but you could make this a permanent one. I'm just going to call this time label. And I'm going to make it a point data set and put it into the same coordinate system as the rest of my data. And I don't need any attributes. An empty point data set is all I need. And I'm just going to put a point for this layer on the map where I want to see time displayed. So maybe I'll put it in this empty area here and stop editing. So now I have my time point, but I don't really need to see the point. So I'm going to choose no symbols for the time label. I only need the label text to show up. So I'm going to create a single label for this point feature, and I don't have any attributes. So what I'm going to do is create an expression. And with the temporal controller, there are some variables. So there's one called map start time right here. Start of the map's temporal time range as a date time value. So I can put that in here, and you can see that it's got a preview of the date time. I only really need the year because I'm showing 170 years of data. So I can use this function called format date to put this into a better format for my label. And let me pull up the help for this so that you can see what's involved. So with this format date function, there are these little keywords for defining everything from years down to milliseconds. And so I just want the year, and the year is Y. So I'm just going to enter a single apostrophe Y, and a closing one and close the parenthesis. And so now it's just going to show the year on the map. So I can click OK, and then just give it, maybe a more interesting font. I have a digital one here that I use for this sometimes. Digital 7. And I can make this bigger. So now I have the timestamp on the map. And so as I scrub through time, it should change. But there's one other thing I have to do to this. This also has to be defined as a temporal layer. So I'm going to open up the layer properties for my time label. And on the temporal tab, enable dynamic temporal control. But for this one, I'm just going to tell QGIS to redraw layer only. And that'll force QGIS to redraw this feature every time frame. And it's using the map start time variable for its label content. And so now as I scrub forward in time, that label will refresh and show the time that we're at with the current frame. So yeah, before I got into that,
can I ask about something?
Mhm.
Would it be difficult to add, like instead of just having 1 year, to have like the time period that is visible on the map? Because we're adding things, right? We are not just
Mhm.
showing the buildings that were built in that particular year, but it would be like, I don't know, 1100 until 1936.
Yeah, you could, let's see,
I don't know if that would be too difficult to use, to edit there. Like, yeah, I guess somewhere there to have like the first year and then the second would be updated
this is
the
enough
year
simple
that you
range.
have.
Yeah, I know it's possible.
Yeah. Well, it might be probably easier just to have what you have already and then add another thing exactly like this with a static year, just to add the beginning of the year and then have only the second one changing.
Yep, yeah, so you could certainly do,
You know what I mean? Like, I think that would be probably just
1850, and then
easiest.
you would
That's what I
use,
would do in my very like low tech version of that. But
you do something like this where you just use a couple of these concatenation operators
yeah,
to say 1850 to,
yeah. Or I was thinking even simpler, just to, oh yeah, that looks good. Yeah.
so you could do something like that. But I think there's a way to put that into an expression too. I'll just have to think about it a little more.
Yeah. Okay. Yeah, makes sense.
Good idea. I love it when there's something I hadn't thought of like that. So there's different ways to express time, and there's also temporal symbology you can use. So this is a temporal animation I did of a bike ride I did last year from my watch, my GPS watch, and I got all the points. And you can see that it's fading with time. The size of the dot kind of looks like a slug in this trail. And I have this clock up here showing that. So there's also, we just looked at geometry generators. Believe it or not, this is a single point styled as a clock using some complex geometry generator expressions. This is actually in the QGIS style repository. Topi Chupanov from Finland created this, and this took quite a bit of tweaking to get it to work because of the coordinate system and things like that. But you can do some really cool things with the geometry generator that can make a temporal animation look even better. And there's a lot of different, this is what this animation looks like once you stitch it all together into a GIF. It will play like this, and you can control the speed at which it plays as well. And there's a lot of other kinds of data that you can do this for. This is an animation of some Arctic terns that follow summer from one pole to the other. And I got this data from the GPS on these birds and was able to show a temporal animation of how fast they're able to move from one pole to the other. So again, just the speed at which that happens is pretty fascinating. And there's also a little blending mode happening here, like I think a feature blending mode of addition to show the density of points a little better. And then when COVID-19 hit, I created this temporal animation from the New York Times open data of the outbreak in the United States in the first 6 months. And you could see the parts of the country where it started. And I did this as cases per 1 million people. So you kind of got the, not just a density of people, but density of cases. So there's a lot of things like that that you can use with the temporal controller to animate different kinds of temporal data. And I think it's, certainly an important part of data that's gonna, and I think this temporal aspect of data is going to become more important now that we have some nice tools for being able to show that aspect of our data. And I should also show you that if I were to create a new print layout and add the, just add a quick map, with the temporal controller, it's also something you can configure in a print composition. So down here for a map, there's a temporal range option. So I can choose in a print composition, if I have temporal data, to show just a certain portion of that data on a map composition. And there's data defined overrides for this too. So, you could probably figure out some creative things here. You could also do an animation using the QGIS Atlas functionality with temporal controller and expressions. So there's a lot of possibilities there.
Yeah, it looks like it has huge potential.
So the next thing we're going to move into is the 3D environment. And I have a project for Mount Rainier, which we already looked at and did some data styling for. I could have the contours turned on here. I just don't happen to right now. If I want to see this in 3D, I simply go to the view menu and you'll see that there's this 3D map views available. So I can choose to open up a new 3D map view. And you'll see how this panel, it becomes a panel and it tries to dock, and on the laptop, this can be a little annoying. There's a new feature that was just added at QGIS 3.2.4, this dock undock. So I can actually uncheck that and this window will not try to dock, which can be handy when you're working on a laptop with 3D. So that's one nice improvement that came at 3.2.4 in the 3D view. But when you open up a 3D view, you just have to do some basic configuration. So I click on the little tool here and choose configure to set up the view. And I just need to tell QGIS that it's not flat terrain, it's a DEM raster layer. And it's kind of a, this big red error pops up. I just have to tell QGIS what the elevation data set is, and it's fine. So I can click OK. And now it kind of warps this into a 3D view. And I can use these controls here to start to tilt the data set so I can see it in a 3D perspective. And I can use these tools to rotate and zoom in, zoom out. And there's also a series of, you can add keyframes to this. But before I get into that, you see how there's like some tiling going on here and seeing some slivers that aren't so nice. That can be fixed by going into the configuration here, and this skirt height option. If I increase this value in the skirt height, it will basically, it'll eliminate those slivers between different tiles, or at least usually for the most part. Yeah, they're not really appearing as strongly as they were before. If you want to create a 3D fly-through animation, that's possible to do here. You basically click this little play button and it opens up this panel across the bottom of the 3D view. And you can see it has some keyframes here. It has one at 0 seconds and one at 5 seconds. So I can start basically just adding keyframes. So I could, rotate this map and click the plus button and add a keyframe at 2 seconds for this. And I could just kind of continue to rotate it and do a tour around the mountain like this, add another one at 4 seconds. And you just create a series of keyframes, zoomed in, zoomed out, however you want to show the terrain. or the data. And so once you've created a series of keyframes, then you can simply press play and it will move from one to the next and rotate, in this case, the mountain, and see it from all sides. And then if I wanted to create an animation the same way with the temporal controller, I would click this export animation frames. It's a very similar dialog. It's going to export the same series of still images, and I stitch them together the same way I would with the output from the temporal controller. There are some other nice features in here. There is a measure tool that will measure 3D distances. There's also, you can just save this image if you want to. There's also another open source software called Blender that's used for, video games and the film industry to create 3D scenes and videos. And you can export out this into a format that you could import into Blender and improve on it. So it's possible to pull things out of this and use it in other environments. So 3D views are fairly straightforward to create. And another enhancements that was just added to this environment at 3.2.4 is there's now a basically a 3D view manager. So this doesn't exist in 3.2.2. This is a new feature to manage 3D views, and it will let you store multiple 3D views in your project, and you can do things like rename them and manage them that way. Before this, the 3.2.2 and before, when you close a project, the 3D view goes away and you have to recreate it. So the 3D part of QGIS is still fairly new, so it's being added to each new release. It's probably one of the most quickly evolving parts of the interface. But I can, now that I renamed this, I can hit show and it will open up that 3D view that I've saved. So that's, and it's not just for raster data. The 3D view will also can be used with vector data. If you have vector data and you have points, for example, you could extrude points into 3D space based on a data value. So if you have data for, well, if I open up the buildings project that we were just working with, and I go into layer properties, symbology. There's a 3D view section. And so you can set up 3D symbology for vector data as well, and then use the 3D shapes and graphics to create 3D views of that. So you could actually create like a little 3D model of trees or buildings, or you can just extrude the point into 3D space. And we don't really have time to go into all that, but I just want to introduce it to you. The last topic we're going to get into is mesh data. So this is it's not going to be applicable to everyone, but it's interesting, and it's a whole new supported data model. So I think it's important to cover, and it's basically, again, a collection of vertices. If you ever worked in the Esri environment, you may have heard of TIN data sets, triangulated irregular networks, which are basically mesh data. So the structure can be a regular grid or triangles or irregular geometries. So it has these faces and edges, and there's also a raster component. And again, this is used a lot for weather data, hydrological data, things like that. And one of the interesting things about mesh data is that a single file can have multiple data elements. So it can have, we're going to look at a data set here that has both temperature and wind, but it also has time. So mesh data can also have a temporal component, and so we can use the temporal controller with it. So at that point, this is a mesh data set of the 2017 hurricane season at the Atlantic, when there was like 4 Category 5 hurricanes that hit the Caribbean and the Southeast US. And so with mesh data, you have a raster component here, which is the blue to red strength of wind, but you also have the direction of wind, these traces that can be styled in different ways. And then you can export a series of images through time with the temporal controller and create animations like this, which can be pretty stunning. And I just did one recently of that Hurricane Ian that just hit Cuba and Florida in late September. And what we're going to look at now is the biggest storm that ever hit Denmark. So this is in 1999, and it was a big kind of Nordic hurricane that whipped through and had the highest recorded wind speeds ever in Denmark. And using the temporal controller, we can create some really interesting animations. So I'm going to start a new project, and it's going to start from scratch with adding the mesh data. And the file format for this is a GRIB file, GRIB, and there's several related file formats that support mesh data in QGIS. This is probably the most common. So I'm just going to drag this in, and we can see the area that's covering. This is Denmark, Norway, Sweden, Germany, the Netherlands over here, part of the UK. So if I add countries to this, and Denmark as separate, we can get a little oriented. And I'm going to change the coordinate system of the map based on the CRS of this data, and then zoom in a little bit. So you can see already that this already is a temporal layer. QGIS recognizes time right away. So if I click on this, it'll open up layer properties. And so you can see this represents a period of 3 days in December 1999. So QGIS automatically recognizes that. And if we look at this layer in the layer styling panel, we see a whole new series of styling tabs for this kind of data. You can see there's, right now it's just being showing the wind, but there's also temperature and total precipitation. So there are a series of different data elements in here that we could choose to work with. And right now, this kind of raster component is called the contours. I don't know why, but we can control like the color ramp and things like that from this contours tab. So I can change this to something other than this default, like let's see, red, yellow, green, or yeah, like that. And then invert this color ramp so that it's gonna, maybe I think it's not the one I wanted. I wanted red, yellow, blue. Invert that. So the higher wind speeds will be in red, and the lower wind speeds will be in blue. There's also, yeah.
Can I just see how the attribute table looks like? So the QGIS automatically recognizes that it's a temporal data set?
Yeah, it doesn't have an attribute table.
Ah, okay. What is the source of the data then?
The source of the data is this Copernicus.
Yeah, I know.
Yep.
It's an EU agency. It's based in Prague, actually.
Cool. And you can download this data here or anywhere in the world for any time all the way back to 1959. So and you can choose which components.
I'm just wondering what kind of if I had my own data that I would like to have in a way that it is then used as the temporal data in QGIS, in what way it has to look like.
So yeah, the time is just embedded in this data set. It's part of the format, part of the specification of the data. And there are tools. There's a series of mesh tools in QGIS.
Yeah.
So you can actually
because for the one that we did before with the buildings, that's quite straightforward. But then you can just, you have the build, you have a point, and then there's the date. But like for this one, I cannot even begin to imagine how the like the underlying data looks like. But I guess it's more sophisticated than I would ever work with, I guess. So it doesn't really matter that much. Or like if I had it, I would probably just download it from open sources. But
yeah, or I
just
mean, you can obtain it for the same source this is from. So you know, if there was a big storm that hit Mali, for example, or something like that, you could show that.
No, but I'm just wondering how to do it, because, for example, I'm just like imagining it and kind of like area, you know, controlled by terrorist groups in several months as we receive the information, but it's not information that's publicly available. It's nothing that I could download, but it's information that I have that I could, you know, gather, but I wouldn't know how to put that into this format.
Right, and this format is really specifically for, like I said, weather or hydrology typically. So if you're not working with that topic, this probably would not apply.
Yeah, wouldn't that be useful? Yeah.
Yeah.
Okay.
So
yeah, I was
kind
just
of
wondering.
a specialized format for specific kinds of data.
Yeah. Awesome. Thank you.
I also just have a question since you went on to the ERA 5. So I've downloaded some of that before, and normally that file type is a net CDF, and
that's one of the mesh formats.
Yeah, but I can see that. So if this came from ERA 5, but it's a GRIB file, how come it's a GRIB rather than net CDF? Is that something that you've done, or is that just another download option?
I think they offer that as an option. Yeah, you can choose GRIB or net CDF.
I say I've probably just ignored it all the time because I've been told to get net CDF. Never mind. Thank you. All right, cheers.
But there are tools in here for creating mesh. There's more. This is another rapidly expanding part of QGIS. So it's possible to, there's a plugin called Crayfish that was made by the same company that developed this technology, Lutra Consulting. And so it adds part of some tools to the toolbox. And so it's possible to take things like Saga hydrological flows and convert them to GRIB. So, and there's a mesh calculator tool too. So it is possible to import, export some formats into GRIB and mesh generally. So what we can do is go back to layer styling. And so the contours are activated, but these things called vectors are not. But I can just click on this little vector icon here to activate the wind vectors. So now we're seeing those, and I can go to the vector tab here to adjust how those look. So first off, I can choose the color. I can choose, you know, in this case, maybe like a dark blue for them instead of black to make them blend into the map a little more. I can also choose this display on user grid, and I can go in here and change the size of the grid to make make them a little more dispersed, like maybe 15 by 15 pixels instead of 10 by 10. And down here, the arrow length is defined by min and max, and I can choose scaled to magnitude, which would be magnitude of the wind. And the default value of 10 is way too high. It's a little crazy. So it's going to change basically the size of the arrow. So they're bigger out here where the wind is stronger than it is here where the wind is weaker. Another thing I forgot to change is back here on this contours tab. You can also control, just like you can for a raster, kind of the stretch of the data. So I could enter a smaller max value here to get the higher winds accentuated a bit more. And we could then open up the temporal controller and start scrubbing through time and see, you know, when the bulk of the storm starts hitting, and you can actually see the vortex of the storm right there. But on this vector tab, arrows is just one symbology option. There's also streamlines, which can get quite dense, and you have to do a lot of tweaking to the display of those to get them to look better. The one I really prefer is the traces, which show this wind trace, and here again you can control the particle count or the tail length of those. So I could reduce that to 75 instead of 100 to make them a little shorter. And we can start getting a real sense of when and how the storm passed over the country. This data gets a little large, so it takes a little more time to refresh between steps. So it really doesn't end up looking as good as the final animation would look. You have to kind of sit here and wait for each frame to be rendered. But when you export a series of still images into a GIF, it's very smooth. And again, you can control the step and the animation range and all the rest, just like you could with any other temporal data set. So that's a little bit on mesh data and where to download it and things like that. So that's pretty much all the content I was going to cover today. And we started a little late, but we did manage to get through all of it. I don't think there was anything else major I was going to show. Oh, except that I do have an example of this. There's here in Denmark, you can also obtain lightning data. So to really add more to this, I brought in the lightning data, and it kind of fades in. So there's some temporal symbology, and I can send you some notes on and some screenshots of how this temporal symbology is done. It takes time to figure out, but it's basically using a data-defined override with time. So for example, if I open up the project for the building temporal animation. Here, if we go into the layer styling panel for these points, you can go in here and for the size, click on the data defined override and go down to this thing called the assistant, which allows you to enter an expression here using the map start time and control the values of the points, the size of the points and things like that. So that's where it's done, but I just don't have time to really go through all the nitty-gritty details of that. But I'm always happy to answer specific questions on your data, or maybe next week for the question answer period, go through some more of that.
Yeah, that sounds good to me. I'll definitely make the next Q&A.
Great. So any questions before we wrap up for the day?
Yeah, so on like mesh data and stuff, I saw a post recently about because I've been using a little bit of like GDAL just because it's a lot of like raster data I've been using. I've heard somebody mention something called MDAL, which is, I think, is that like a bit more of a recent development, which it's like GDAL but for mesh data where when it's a bit more unstructured. I was wondering if you might know anything about that, or if there's any
Yeah,
crossover with this
it's
stuff.
the mesh data abstraction library, and it was developed to support mesh data, and is built into QGIS now. So when you're going into things like from the mesh menu to the mesh calculator, this is using MDAL under the hood to handle that. And the same would be true if you're going to export a mesh data set out, which you can do if you have a mesh data set open. Mesh MDAL, so GDAL is for reading and writing raster data, and has utilities for doing all sorts of things with raster data. And MDAL is basically the mesh equivalent of that for manipulating reading and writing mesh data sets.
Okay.
And
like what's really like the difference between mesh data and like a series of polygons adjacent to each other? Like there must be like extra information, I guess, that makes it mesh as opposed to just sort of polygon locations, right?
yeah, it's because it literally has literally has this structure here, one of these structures here, where you actually have these mesh faces. So for example, you can convert an elevation data set to mesh to create a mesh surface for the terrain. And in some ways it can be more efficient, because let's say a raster data set has 10-meter resolution, and it has 10-meter resolution across the data set, even if there's not much variability in the elevations. Whereas a mesh data set can have larger faces where there's more homogeneous terrain, and smaller faces where there's cliffs and more complex terrain. So it is composed of this underlying literal mesh structure, and then the tools in QGIS allow you to both show that as kind of a raster equivalent, as contours, or as the streamline traces as well. So, but the underlying structure is going to be one of these three.
Okay.
And it is that, so it's kind of vector-like in a sense. But like just doesn't have attributes that you can access in a standard table format. It doesn't have features. So in that way, it's kind of more similar to raster data, but it is kind of a hybrid between the two, is the way I think of it. But
can you like, are there parameters that you can add to it to sort of define the maximum number of faces that a cell can have, and stuff like that?
I don't know about that. There is a mesh editor that came out where you can actually edit mesh now, and change the shape and of different faces and edit those.
Yeah, I should say the reason I'm particularly doing this is asking is because a lot of the work I'm doing at the moment is in a piece of software called HECRAS, which is
a
hydraulic modeling software, and there's tools for modifying the mesh inside of that. And yeah, I just wondered if I'd be able to do it outside of that and then import it in. But then there are certain for like hydraulic reasons, there are certain constraints on what you can do inside of HECRAS. But yeah, so particularly niche question. Sorry, Blanca.
This is the so here we are. Anyway, I brought in a mesh data set, so I hopefully should be able to. I don't know why the mesh, maybe it's because of the format, but this is the mesh toolbar here that is not active, but it has tools for querying mesh elements and things like that. So this is brand new. This has only been out for a couple months, so I'm not really sure everything it can do, but I recommend you explore this. And Lutra Consulting, based in the UK, is the company that is developing MDAL and all the mesh functionality, as well as the 3D environment. And so you might look up Lutra Consulting, because their blog posts series will usually break down new features and things like that related to when there's new functionality like this. So or look at the visual change logs as well.
Okay. Yeah, no, I've heard of them. I follow, I think there's a guy called Vincent Klowarek. I think he works for them, but I thought that he was French Canadian. So I'm
well, they're
surprised.
based in the UK, but I think there's only 1 or 2 employees in the UK. They have quite a few Czech employees, Slovakia. So they're distributed, Italy, they're distributed around all of Europe.
Okay. Yeah, great. No, I'll check them out. Yeah, because they seem to be pretty much on the cutting edge of what's happening with QGIS.
Yeah, absolutely. Okay. Well, we went over a little bit, but we started late, so I feel like we came in at about 2 hours. So hope you guys have a good week, and see you next week for the Q&A session. And I'll send out a reminder so that we get the time right. And let me know in the meantime if you have other questions that pop up.
Yeah, great. Okay, thanks very much.
Yeah.
I'll try to work on my assignments.
Okay, great.
Over the weekend. Okay, thanks a lot.
Thanks,
Oh, you're welcome.
Bye,
Bye,
guys.
Have a good day. Bye.